Hello everyone and welcome to the ABB webinars. I see we have still a few people trying to log in, so we will give them a few more seconds before we get underway. Please bear with us. Couple more seconds. Okay, I think we're all here. Thank you everyone for joining us today. I'm standing in for Anna Knight. My name is Isabel Stope, and I would like to officially welcome you to Industrial UPS, presented by Adam Cockerill. Before we get started, just 6 quick housekeeping rules. In front of you, you will see the presentation, and to the right of your screen is your control panel, where you can control your connectivity. And also, if you have any want to speak to the host, you can use the chat box, which is a little bubble on the bottom of your screen, to communicate with me. And also, we will be having a Q&A session at the end of the presentation, but please feel free during the webinar to ask your questions, or rather type them in that Q&A box on the right-hand side in the panel. All questions will be answered at the end of the webinar, and should we run out of time, they will be taken offline. Everyone has been muted by design. There will be a short survey at the end of the webinar, and we'd really like you to take a few seconds to give us your valuable feedback. The webinar will be recorded and made available on our website. And with that, I'd like to hand over to Adam, and I will be back with you for Q&A. Thank you. Adam, over to you.
Thanks, Isabel. As Isabel pointed out, my name's Adam Cockerill. I'm the Product Marketing Manager for Power Protection Products here in Australia. I'm going to run through our industrial UPS. What I'll do is I'll just drop off the screen so that the presentation is not impeded by having me here. And I'll jump back on for questions at the end. Hope you enjoy the presentation. So our industrial UPS is our PowerLine DPA. DPA standing for Decentralized Parallel Architecture. So it's a modular UPS with a design life of 15 to 25 years. So obviously we're in the industrial space. We're looking in your oil and gas segments and mining and anywhere where an industrial type UPS is designed for the particular application. What I'd like to highlight with our products, this goes for all our DPA range and carries over into our PowerLine, which is our industrial UPS, is our availability. So availability is a measure of reliability, or mean time between failures, and serviceability, which is your mean time to repair. So as you can see there, down the bottom there on the right hand side of your screen, 99.49% availability, which means over a time of 15 years, you can be looking at 8 minutes or less of downtime, which is an order of 10 improvement on our competition, and really shows the availability of our unit and how this can really assist in applications such as an oil and mining venture, where you may be considerable distance from your local township or your local service department, and the requirement to be able to, one, have redundancy built into the UPS, and two, be able to repair or substitute a power module out relatively quickly and with relative ease is something that our customers are really seeing the benefit of from this particular UPS. Just highlighting in this slide here the difference between the monolithic UPS, so paralleling to 40 kVA UPSs in this instance, and gives you availability of 99.39%, as opposed to what we're looking at here, which is 6 nines. So we're improving, as I said before, by an order of 10. You can see that each UPS, our module is a complete UPS, has an internal static switch, which each module itself is a complete UPS without the battery component, of course, but it shows you how we can limit the amount of spare parts that's also required on site. The spare part or the spare component that is required is actually a UPS module, and this can be a common spare across multiple units and installations across your site. And as I'd like to just point out here, we can change this module in under 10 minutes. So that's from powering down the module, removing the module, replacing with a new module, and then powering back up and ensuring that it's back into the parallel system with the other module or other modules that are online. So just running through the key benefits here, I'd like to really highlight the temperature that we can run this unit in, up to 45 degrees without derating. These are unity power factor modules, so either 20 or 40 kilowatt modules, unity power factor. There are options which I'll get to later in the presentation with what we can look at as far as added redundancy as well. We have type test certifications for multiple industries, and we can go into that either offline or later if that is something that we would like to do. The standard enclosure is an IP31 enclosure. We can upgrade this as an option to IP42. So this unit comes as a 3-1 or a 3-3 system, so 3-phase in, single phase out, or 3-phase in, 3-phase out. Now, as I alluded to a little bit earlier, so a modular decentralized DPA, so decentralized parallel architecture. So each module itself includes rectifier, inverter, static switch, battery, DC to DC battery or booster, and integrated backfeed protection. All the modules that are in Australia come out with conformal coding. So anything that comes into Australia, that is an option, but we include it as standard on all our modules into Australia with conformal coding. And as you can see through there, we have a HMI or a LED screen on the outside there that you can see what the total system load is doing. Each module itself has an integrated control logic on the front, so you can go down and look at module level, and you can also look at the parallel system from the external display there. The options on these units are transformers. So you have your input transformer bypass and output transformer, sized to the capacity of the module, sized to the capacity of the UPS, sorry. And as I mentioned before, IP42, we can do top or bottom cable entry. Anti-condensation heaters, depending on what your application is, whether you're requiring the unit, or if it's in an environment where condensation buildup is a problem. We can cover that off. Obviously, conformal coding, as I said before, is a standard in the modules in Australia. We can also build in redundant fans, which are all monitored by the module, and an alert comes out if one of them fails. And temperature sensor into the batteries, and we can also do what is called a redundant configuration. So that's essentially two UPSs sitting side by side. So if we're taking the 80 kVA as an example, you have two 40 kilowatt modules as the 80 kilowatt UPS, then you have a further two 40 kilowatt modules as a complete redundant UPS. So you can get N plus N and N plus 1 redundancy within these units. The modules can also be optioned with a battery cold start as well. Now, just delving a little bit more into the DPA, which is once again decentralized parallel architecture. I know it's a mouthful, but what it does show there is each module itself, each UPS module has a rectifier, DC to DC converter or booster, battery booster, an inverter, and a static switch. Also, it has a control, display, and logic inbuilt to every module. Every UPS, every module is a complete UPS. As you can see, it's paralleled on the input, parallel on the output, and we can either common up batteries or we can use individual batteries per module as well. These are IGBT rectifiers and inverters, and we can do a simultaneous power flow from the batteries in the mains, so we can do a dual source to give you the walk-in from a discharge when mains is returned. We walk that back in from batteries into mains and vice versa. Now, with the batteries that with this unit here, we, as you can see there, VRLA as standard, 42 to 48 blocks, 12 volt blocks that is, NiCad and lithium ion. So this is an industrial unit that is ready for lithium ion right from the outset. There is no midpoint on these batteries, so it's a positive, negative battery feed. Internal of the module, as you can see there, the booster, the inverter, the battery, and bypass are all measured for temperature. So this is, as we said, it's an industrial UPS. The redundancies internally with fans and conformal coating, and the fact that we are monitoring components down to component level for heat shows you how we can deliver the availability and reliability that has become known from this product. Bit of an understanding, so opening the doors up and seeing exactly how this UPS comes together. As you can see over here, we've got a 40 kilowatt module. The module itself has its own display, and right next to it is another 40 kilowatt module. So this is what's called the active side of the frame. On this side here, this is what's called the passive side of the frame. You can see that we've got all the switching. So you've got your input, your output, your bypass switch, and your transformers, if they are to be optioned in, are included in this passive side of the frame. So electrically, you can completely isolate yourself while working on this frame for maintenance or replacement purposes. I'll let you absorb this SLD for a couple of seconds. Each module there, as you can see, the parallel system. Bit of an understanding of how these modules and how they perform, what these modules are and how they perform. As you can see, we have two module sizes, a 20 kilowatt and a 40 kilowatt. They, as I mentioned before, they are unity power factor. Out from the factory, we can see how easy these are to move in and out. We have handles on the front. They simply slide in and out and mount to a back plane in the frame. 4 screws, and these can be removed. Now, these are online hot swappable modules. Providing you have redundancy in your system, these can be changed online at any point in time for either maintenance or replacement purposes. This is the tech data for our 3-in single out. So previous slide was for 3-in, 3-out. So 3-phase in, 3-phase out, and 3-phase in, single phase out. This just shows you the external display. So on each module display, it gives you what that module is doing, what load that module is running. Excuse me. On the external display, it gives you a system overview, so you can see how the whole system is loaded, and it gives you a mimic screen there. You can see whether it's online and what mode it's in. This is the same information that is sent through Ethernet and Modbus. You can pick up on your web page if you've set it up like that, or through your BMS locally as well. So this is showing the full system status and giving you full visibility over what the system is doing. Also giving you full control from the front screen. You can control both modules at once. If you were to open the front door, you can control the individual module for replacement and maintenance purposes. And a bit of just an understanding of the connectivity pathway. Pretty standard stuff here through TCP, Modbus, and how we can get to your shutdown servers, and if you're looking at utilizing that side of the communications for shutdown, or whether you're using it for monitoring purposes, how we can connect. As far as the life cycle of this unit, it is an industrial UPS. We are design life 20+ years, and just illustrating the life cycle that these units go through. So replacing fans and capacitors at your 5 and 6 year mark, and then moving through your normal life cycle replacements to replacing your module at the 15-year plus mark. Obviously dependent on environment and making sure we've got regular maintenance and looking after these components as well. Also a bit of an illustration on our availability, just how we can change these components. So not only is the UPS module itself modular, our component replacement is modular, so it can decrease the amount of time that the techs need to spend on site and going through and doing your life cycle maintenance. As you can see there, you've got AC input and output filter caps there, and you've got your fans at the top of the module, which also could include your redundant fans and your DC caps that can be accessed through the side of the module. What I'd like to do is just, in conclusion, give a bit of an overview as to the whole power protection portfolio. Obviously, what I've given an overview here today is of the PowerLine UPS, which is our industrial UPS. We also have single conversion UPSs in the industrial space from our New Zealand factory. So MV UPS and the PCS 100 UPS-I, which if you want information, I'm more than happy to provide, or do a one-on-one or a group session on this, back and through to our commercial offering. So we have our single phase power value, power scale, which is 3-phase, and our power wave, our large monolithic UPS, our double conversion modular UPS, so DPA upscale, our ST and RI units, and our DPA 250S4, DPA 500, and our new Megaflex that's in that range there, and our static switches, which is out of our United States factory there. Now, I know that was a brief overview of our industrial UPS. I'm more than happy to take as many questions as we have and start the ball rolling. If we'd like a one-on-one session or a group session, I'm more than happy to take it further as well. Take this offline. Thank you for your time.
Thank you, Adam. Now, before I go through the questions that have been raised, just a reminder that you may continue to type in your questions using that Q&A box on the right-hand side of your screen. in the control panel. If you would type your questions in there, we'll go through them. I will start with the first one. How many and what type of batteries can you be used with the PowerLine?
Yep, not a problem. So I believe we may have covered some of that off. So VRLA batteries as standard, 42 to 48 blocks as a standard. NiCad batteries can be used for industrial purposes, and lithium ion as well. So it's a 512 volt lithium ion cabinet we use. Samsung is the cabinet of choice at this point in time. But yeah, 512 volt block for that. Thank you.
Thank you. The next one is, what is a UPS's life expectancy and what components need to be replaced and when?
Yes, not a problem. We can touch back over that. That's more than happy. So I'll just jump back a couple here. So we're looking at 20-year plus design life for these UPSs. So looking at fans and AC caps at the 5-year mark, and DC caps at your 6-year mark. Obviously, with regular maintenance in between, we can extend the life expectancy out to 25 years for this particular UPS, industrial UPS.
Thank you. And what is the size of the transformer enclosure for the transformer option?
Oh, good question. Okay, so the up to 120 kVA, all the transformers are enclosed in the passive side of that frame, so we can have an input, an output, and a bypass transformer without impeding your footprint. It is internal, obviously an option, but it is internal of that frame and can be, so there's no need for any external cabinets or enclosures for up to 120 kVA with this UPS.
Thank you. Okay, this is a two-part question. I'll try to break it up for you. How does the system synchronize itself with the network? And can you have two units sitting approximately 2 kilometers away from each other work synchronously if the loads are very phase sensitive?
That is a question that I would like to take offline with that particular person who's asked that. That is a very involved question. I'm not sure that people that are online at the moment might get benefit from that. So please, Isabel, could you pass those details through to me, and I'd like to get in contact with that person.
Not a problem. So we will answer that one offline. So yes, I will make a note of that, and we will be in touch with that, or you rather will be in touch with that person to give them a full answer. At the moment, I don't have any more questions, but I'd like to give everyone a few more seconds if they'd like to type in anything before we conclude the webinar. So let's just give everyone some time to see if there are any more questions. Very shy audience today. Oh, hold on a second. I'm getting some in the chat versus the Q&A. Give me 1 second to flip around. Sorry. Here we go. Why are NiCad batteries still being used? Mature solution?
Look, to be perfectly honest, the NiCad batteries are still in use. There are some hostile environments out there that are still being used where a VRLA or a lithium-ion solution is not the best option. As you may or may not be aware, NiCad is comfortable in much harsher environments than both the VRLA and lithium-ion especially. So there are particular applications where NiCad is still the preferred option. We do find that in a lot of industrial applications that NiCad is still a preferred method of energy storage.
Excellent. Now let me just go back to my questions. I think we've got one more. Sorry, I just have to flip around. Let's see what this one is about. Oh, it's not relevant to this. It's something about another webinar. Here we go. What is the main purpose of having 2 or more modules with the UPS instead of just having one?
So as I made mention to earlier in the slide, I'll see if I can jump back and find the slide. So it's about availability and about redundancy. So if we were to look at an existing single monolithic UPS, if we were to take this example here of, say, let's have a 120 kVA UPS here feeding down onto your site into your critical load. If you have an issue with that 120 kVA UPS, say you've sized that at 50%, so you're looking at a 60 kVA load, you can have a single failure or a single issue with that unit, or even for maintenance purposes, you need to go to bypass. You put your UPS, you put your load onto raw mains, and potentially expose yourself to what raw mains can provide. By using our modular system, you can remove one module from that UPS to provide or to do maintenance or do a replacement, and you can be online still operating without any issues. What it also does is, if there is any unforeseen failure or problem with the UPS, it can remove a module automatically from the system, and you've still got your redundancy inbuilt to the UPS itself. And if the question is pertaining to the full redundant system, so the one that is 2 frames, so you have a frame this side, an active frame this side with a passive frame in the middle, and another active frame on the other side, which is the redundant option that you can offer, you just increase that redundancy availability. Mean time to repair is increased by having more levels of redundancy. So in particular, for applications, as I mentioned earlier, where you're looking at a long journey, possibly from technician to get to site, or delays on getting to site, the site could have a module as a spare across multiple different UPSs that if it's required, could be used, or indeed you have an internal spare already online and working already, and your critical load is not compromised.
Excellent. That is all I have for the moment. So that will take us to conclude our webinar. Thank you everyone for attending. We hope you found it useful. I'd like to remind everyone that there is a short survey that will pop up on your screen when we close the webinar. And if you could take a few seconds to give us your feedback, that will be great. And we hope to see you at future ABB webinars in the future. So goodbye, everybody. Thank you for attending, and stay safe. Thank you, Adam.
Thank you. Thanks, Isabel. Thanks, everybody. Bye.